China just assembled a fully livable 10-story apartment building. Walls, windows, balconies, plumbing, wiring, all of it. In 28 hours and 45 minutes. 28 hours. In London, that same building takes 3 years from permit to keys. 3 years versus a day and a bit. You heard that right. But here's the thing. The speed isn't even the story. The speed is the part that gets the clicks. The real story is the man who built it, the earthquake that broke something inside him, and the one question he asked that the entire global construction industry had spent 100 years running away from. And that question, it starts in the rubble. It starts in Sichuan. Stay with me, because by the end of this, you're going to see a number so absurd it sounds invented. A building engineered to stand for 1,000 years, assembled in less time than a long lunch. It shouldn't be possible. It is. If you're into the stories of how China keeps doing the thing everyone said couldn't be done, subscribe now, because this is exactly that story. Let me tell you about Zhang Yue before we talk about a single building, because here's what nobody expects. He wasn't a construction man. He didn't pour concrete. He didn't raise frames. He ran an air conditioning company. Broad Group, based in Changsha, was one of China's leading HVAC manufacturers. Industrial cooling, climate systems, precision engineering applied to temperature. That was his entire world. Not walls, not foundations, not the question of whether the building you're sleeping inside tonight will still be standing when the ground starts to move. And then the ground started to move. May 12, 2008. Sichuan, China. Magnitude 7.9. And when the shaking finally stopped, 70,000 people were dead. Sit with that number for a second. 70,000. That's roughly the entire population of Cambridge, England, gone in under 2 minutes. Most of them buried under concrete, under the very buildings that were supposed to protect them. Zhang Yue watched the footage. He watched rescue crews pulling children out of school buildings that had pancaked flat, floor pressing down onto floor like a stack of collapsed shelves. He watched apartment blocks fold in 40 seconds. And he watched engineers stand calmly in front of cameras and explain that the buildings had met code. That this is just what concrete does when the earth moves hard enough. And that's where something broke in him. Not grief, though there was grief. Something more dangerous than grief. A question. Why are we still building this way? Now here's the part most people never stop to think about. The technology to build differently already existed in 2008. Steel modular construction had been demonstrated. Prefabricated systems had been tested. The engineering knowledge was sitting right there. But the construction industry, and not just in China, everywhere on Earth, had spent a century perfecting concrete, scaling concrete, writing its codes around concrete, training its entire workforce on concrete. Changing that system felt like turning a cargo ship with a single rowing oar. So nobody seriously tried. Zhang Yue wasn't interested in the cargo ship. He pulled his engineering teams off air conditioning. He redirected Broad Group's entire manufacturing operation. And he gave them one target: build a system so obviously, undeniably superior that no engineer standing in front of a camera could ever again explain a collapse by saying the building met code. Years of failed prototypes followed, scrap designs. There were moments the whole thing looked like a billionaire's vanity project, ambitious, expensive, and quietly going nowhere. Then it started working, and what he built didn't just answer his question. It made every conventional construction method on Earth look like it belongs in a different century. But before you can see what Broad Group built, you need to understand what they built it out of. Because the material is the part that silences every skeptic in the room. Picture a shipping container. You've seen them on trucks, on cargo ships, stacked in ports. You know the size of one intuitively. Now imagine that container isn't carrying goods. It is the building. A fully finished slice of a floor, walls in place, conduit already run, windows fitted, balcony railing already welded on. You crane it off a truck, you bolt it to the one below, and you're not assembling a building anymore. You're stacking one, like flat pack furniture, at skyscraper scale. And it starts not on a construction site, but inside a factory. The Broad Group facility in Changsha covers 230,000 square meters. That's roughly 32 football pitches under a single roof. Every component of every Broad Group structure is built inside that controlled environment. No rain delays, no site accidents, no delivery stuck 3 cities away. When a module leaves that factory, it's not a raw part waiting to be finished. It's a finished room waiting to be stacked. Here's the detail that puts the whole thing into perspective. Traditional construction works outside in. You pour a foundation, raise a frame, run conduit through walls after the fact, hang drywall over the wiring, and someone inspects it next month. Every trade works in sequence. Every delay compounds. And every mistake gets buried inside a wall where nobody finds it until something stops working. Broad Group works inside out. Every system installed, tested, and verified before the module ever leaves the building. The thing is essentially complete before it touches the site. Now here's where the skeptic in the room usually speaks up, and honestly, the skeptic has a point. Modular construction isn't new. The British tried it after World War II to solve a housing crisis. The Soviets built entire cities out of prefabricated concrete panels, Khrushchevkas, and the results were not inspiring. Most of it was abandoned within a generation. That skeptic is right to bring it up. So here's what makes Broad Group different from every prefab attempt that came before it. The material. They don't build in concrete, they build in steel. High-grade, precision-engineered, factory-welded steel frames. And the difference in structural performance isn't incremental. Steel modules built to Broad Group specification carry loads up to 100 times greater than an equivalent concrete structure under stress. 100 times. Stand a concrete building and a Broad Group steel building side by side. Apply the same catastrophic force to both, and the concrete reaches its failure point before the steel has even begun to strain. Then there's the earthquake data. And this is the part that lands. Independent seismic engineers, not Broad Group's own team, external verifiers, tested the system against simulated seismic loads. The verified result? Resistance to a magnitude 9 earthquake. Now remember, the Sichuan quake that killed 70,000 people was a 7.9, and a magnitude 9 releases roughly 16 times more energy than a 7.9, which means the buildings Zhang Yue now builds would have stood in Sichuan. Not probably, not likely, they would have stood. And then comes the number that stops every conversation cold: structural lifespan. A well-built concrete structure lasts somewhere between 50 and 100 years before its integrity becomes a genuine engineering concern. The Broad Group steel modular system is rated for 1,000 years. 1,000. Say that number back to yourself. That's not a marketing slogan. That's the corrosion rate of the treated steel, the load-bearing degradation curve, the joint integrity timeline, calculated by structural engineers and expressed as a lifespan. A building assembled in 28 hours, engineered to outlast every concrete skyscraper currently standing on the planet. And here's the kicker. The factory model cuts construction waste by 90%. 90% less rubble, 90% less landfill from a single build. Now, here's what most people get wrong about this. They hear prefabricated and they picture gray Soviet housing blocks, compromised buildings that work on paper but feel like prisons to live in. What they don't picture is a 10-story finished apartment block rising out of an empty site in 28 hours and 45 minutes while the neighbors are still watching from across the street. But Broad Group is only half of what China has built, because running in parallel, in a factory on the other side of the country, a completely different technology is solving the exact same problem, in a completely different way. Forget everything you picture when you hear the words 3D printing. Forget the little desktop machine making plastic figurines. What Winsun built in Shanghai is not a printer in any sense your instincts are ready for. It's a gantry system. Think of the arm that moves across a CNC machine. Now scale it until it spans an entire building footprint, rolling on rails, dragging a nozzle the width of your forearm, laying a continuous ribbon of material in precise programmed layers, back and forth, course by course, until a wall is standing where nothing stood an hour ago. And unlike a human crew, it does not stop for lunch. And the material coming out of that nozzle, it isn't virgin concrete. It's a blend of recycled demolition waste, crushed brick, salvaged aggregate, industrial byproducts that would otherwise rot in a landfill, mixed with a fast-setting cement engineered specifically for extrusion. Too wet, and the layers slump. Too dry, and the nozzle clogs. Winsun spent years finding that exact ratio. The result sets in minutes, bonds layer to layer under its own chemistry, and meets Chinese residential building code. Now here's where it gets genuinely insane. In 2014, Winsun printed 10 complete livable houses in a single 24-hour run. Not prototypes, not shells, livable houses, walls, internal divisions, door and window openings, printed, completed, structurally certified in one continuous operation. A traditional crew building 10 houses at once would need months, dozens of workers, and a logistics operation spread across 10 separate sites. Winsun needed one machine and one day, and the material savings are just as staggering. Conventional construction wastes somewhere between 15 and 30% of everything you buy. Winsun's nozzle deposits exactly what the design calls for, nothing more. The result is a reduction in material use of between 30 and 60%. Let that land in human terms. The material saved building 1,000 printed houses is enough to build 300 to 600 more from the same budget. And then came the problem every engineer in the room already saw coming. Printed concrete carries vertical loads beautifully, but concrete is weak under tension. The flexing forces from wind, from thermal movement, from seismic activity. Traditional construction solves this with embedded steel rebar. Threading rebar through a printed wall is possible, but it's complicated, and it remains one of the genuine, unresolved challenges of the technology. And I want to be straight with you here, because this is the part the hype videos skip. This is real. It's not a deal breaker. It's an 18 to 36-month development problem with multiple solutions already being tested. But it is a real limit today. And here's why it actually matters more than people realize. The countries that need this technology most, the ones with the biggest housing deficits, the tightest labor markets, the least time to wait, are also the ones most exposed to earthquakes and extreme weather. So, solving the tension problem isn't a nice to have. For Winsun, it's the difference between a remarkable machine and a truly universal one. And that kind of pressure, that's exactly what produces breakthroughs fast. Because Winsun isn't working in isolation. Broad Group is attacking the same problem from the opposite direction. And together, these two systems represent something the global construction industry has never been forced to confront. Two simultaneous, proven, scalable answers to the question it spent a century refusing to ask. But to understand why those answers matter, you need to see the true scale of what they're answering. Because the housing crisis isn't a policy talking point. It's a number so large, it barely fits inside a single sentence. 100 million. That's the current global shortfall in housing units. 100 million homes that need to exist and don't. To hold that number in your head, picture the entire combined population of Germany, France, and the United Kingdom with nowhere to live. And that's not a projection. That's the number housing economists are working with right now, today. And it's getting worse. Urbanization is accelerating across Southeast Asia, Sub-Saharan Africa, and South Asia faster than conventional construction can possibly respond. The UN estimates 2.5 billion additional people will be living in cities by 2050. 2.5 billion, roughly the combined populations of China and the United States, all moving into urban areas that don't yet have the housing to receive them. And the industry tasked with building it? Slower, more expensive, and more labor-starved than at any point in the last half-century. And here's the part nobody talks about. Construction is one of the least automated industries on Earth. Walk onto a conventional site in London or Sydney, and you are watching methods a builder from 1975 would instantly recognize: pour, wait, build, wait, fit, wait, inspect, wait. The process hasn't structurally changed in 50 years, and the workforce that performs it is aging out faster than it's being replaced. And here's where it gets genuinely alarming. In China, the generation that built the country's extraordinary infrastructure over the last 3 decades is retiring. The generation behind them is not going to construction sites. Meanwhile, China has 260 million people living in urban housing rated to last 50 to 100 years. The replacement clock is already running. This isn't a future problem, it's a present one. And now the market numbers make the stakes real. The global modular construction market hit $95 billion in 2025. By 2034, it's projected to reach $175 billion. Strip away the finance language, and here's what that actually means. Millions of families in countries that cannot afford to wait 3 years for a mid-rise are watching what China built and making a decision. And that growth is not coming from Europe or North America. It's being driven by China, the Gulf states, and Southeast Asian governments that have concluded conventional construction is simply not a viable path forward anymore. The cost curves tell the rest. Traditional construction gets more expensive every single year as labor costs climb and regulation compounds. Factory-built and printed construction gets cheaper as systems scale and material science matures. Two curves moving toward each other, and in some markets, they've already crossed. China crossed that line first, and the result is a construction ecosystem now operating in a different economic reality than the rest of the world. Which brings you right back to the number this whole thing started with: 28 hours and 45 minutes. Now it's time to walk through exactly what happened. Because once you see the mechanics of how a 10-story finished building goes up in less time than it takes to fly from London to New York, it stops feeling like a trick and starts feeling like the most obvious thing in the world. Picture an empty site, cleared ground, a prepared foundation, and a fleet of flatbed trucks lined up down the road. Each truck is carrying a module, not a load of bricks, not a pallet of materials. A finished room, walls up, wiring run, windows seated, balcony railing welded. The room is done. It just isn't stacked yet. And this is where the system does the thing that stops engineers mid-sentence. The modules arrive sequenced, not by floor number, but by crane window. Every lift is scheduled to the minute. The crane operator is never waiting for the next module to show up. The next module is already rolling through the site gate before the previous one is fully bolted down. The choreography is tighter than most people think construction is even capable of being. Here's the detail that makes the speed real. On a conventional high-rise, the structural frame alone, before a single wall, before a single pipe, takes months. Concrete is poured floor by floor, and each pour has to cure before the next begins. Cure time for structural concrete is typically 28 days per pour, 28 days per floor. On a 10-story building, that sequencing alone eats the better part of a year before the finishing trades even show up. Broad Group eliminates that entirely. No cure time, no sequencing delay between structure and fit-out, because the fit-out is already done when the module leaves the factory. The crane lifts a finished floor into position. The connection team bolts it to the floor below. Precision-engineered joints designed to align on the first drop. Then the crane is already lifting the next one, and 28 hours and 45 minutes later, a 10-story finished apartment building is standing where there was empty ground the morning before. Now here's what people get wrong when they hear that number. They assume shortcuts were made. They assume it's fast because something was sacrificed. But the earthquake data, the 1,000-year lifespan, the 90% waste reduction, those are not the numbers of a system that cut corners. They're the numbers of a system that moved the work somewhere the industry never thought to look. Off the site, into the factory, out of the weather, out of the chaos, into a controlled environment where precision is the default. But as extraordinary as that build time is, it's still not the biggest obstacle this technology faces. The biggest obstacle has nothing to do with engineering. And it's the reason a method that can house millions of people faster, cheaper, and safer than anything else on Earth is still not the global standard. Because the wall standing in its way wasn't built out of steel or concrete, it was written. Here's what makes this both maddening and clarifying at once. The technology works. The earthquake data is verified. The build times are documented. The cost curves are moving the right way. There is no credible engineering argument left against modular and printed construction at scale. The case is essentially closed. And yet, in London, a mid-rise still takes 3 years from permit to keys. In New York, the same. In Sydney, in Toronto, in Paris, the same crews, the same sequences, the same process a builder from 1975 would walk onto and immediately recognize. So what is actually in the way? 3 things, and not one of them is technical. First, building codes. The regulatory frameworks governing construction in most Western countries were written for conventional concrete and timber. They specify not just what a building must achieve, load-bearing capacity, fire resistance, thermal performance, but how it must be built. Modular steel and printed concrete frequently meet the performance requirements while failing the method requirements. The code doesn't ask whether the wall holds, it asks whether the wall was built the way the code imagined. And rewriting those codes takes political will and years of process. And nobody inside the current system has much incentive to move fast. Second, supply chains. Every major developer, every large construction firm, every material supplier operates inside an ecosystem built around the old method. Concrete suppliers, timber merchants, bricklaying subcontractors, scaffolding companies. An entire economy exists to service conventional construction. Switching to factory-built modular doesn't just change how buildings go up. It makes large parts of that economy redundant, and the people inside it know that, and they have lobbyists. Third, and here's the part nobody wants to say out loud, the slowness is profitable. A 3-year build timeline isn't just an inefficiency, it's a revenue model. Consultants, project managers, specialist subcontractors, financing arrangements charging interest across multi-year build periods. The duration of conventional construction is not an accident. It's a feature, for everyone getting paid by the month. And the countries watching China most closely are not the ones you'd expect. Not Germany, not the United States. It's the Gulf states, Vietnam, Indonesia, Nigeria, Ethiopia. Countries with housing deficits so acute and labor markets so constrained that they cannot afford the luxury of institutional inertia. They're not debating whether to adopt this. They're debating how fast. So zoom all the way out. 100 million missing homes. A construction workforce aging out of the trade. A climate demanding less waste, less material, less of everything the old method produces by default. And 2 technologies. One stacking finished rooms at skyscraper scale, one printing walls from recycled rubble while the city sleeps, that together answer every part of that problem at once. And this is the thing. It was never really a technology story. Here's the question that actually matters. If the engineering works, and it does, and the economics are moving the right way, and they are, then what kind of world becomes possible when the friction is finally removed? Picture a government in Southeast Asia with 3 million people in inadequate housing right now. Under the old model, that problem has no realistic solution. The labor isn't there, the time isn't there, the money, at conventional costs, isn't there. Under the broad group and win-sun model, that problem has a factory answer. The constraint shifts away from the chaotic, weather-dependent, labor-hungry build site and onto a factory floor where output is a function of investment and process, not of how many bricklayers you can find. And here's the closing argument Zhang Yue has been making ever since he stood in the rubble of Sichuan. We don't have a housing problem because we lack the ability to build. We have a housing problem because we locked ourselves into a method that is slow by design, wasteful by habit, and protected by a system that profits from its own inefficiency. And the proof that a better way works isn't a blueprint. It isn't a proposal. It's a standing building. You can walk into it. You can live in it. China stacks 10 stories in a day. London takes 3 years for a mid-rise. That is not an engineering gap. That is a choices gap. The rest of the world is still pouring concrete and waiting 28 days for each floor to cure. China already moved on. So let me leave you with this. If the better building is already standing, already livable, already proven, then the only thing keeping the old world in place is the people who profit from it staying slow. So here's my question for you. When this technology finally reaches your country, who do you think is going to fight hardest to stop it? Tell me in the comments, and if you want to keep watching the stories of how China keeps building the future while the West argues about it, subscribe, because there's a lot more coming.